Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to identify linear and exponential relationships given a table of values. All right. So the question reads, which table of values represents an exponential relationship? So let's go ahead and talk about the difference between both of them first. All right. So let's recall the following important facts. When you have an exponential relationship, uh, what's the identifying feature? For an exponential relationship, you have repeated multiplication. That is how the terms are generated. All right? Repeated multiplication by a constant factor. Constant factor. Now, how does that differ from a linear relationship? So a linear relationship, the terms are generated by repeated addition or subtraction. Okay? So linear relationship is repeated addition or subtraction by a constant, and that constant is called the common difference. Okay, the differences are common, the common difference. All right, so let's take a look at a generalized representation of an exponential function, an exponential relationship. So let's say we have x and the output f of x. Okay, so this is just a random example just to illustrate the relationship between the terms in the output side of an exponential relationship. All right, so let's say you have inputs 1, 2, 3, 4. Okay, and the first output is x. All right, and an exponential relationship, you're going to have to multiply by a constant factor all the time to generate the output terms. So let's say the constant factor here is x. So the next term is going to be x squared. How did that happen? Well, you multiply the first output by x because that's the constant factor. To generate the next term, what do? You multiply by another x. All right, let's write this clearly so you can see. So you multiply by x, and then the output is going to be x to the third. All right, and then you multiply by x again to get the next output value, and that's going to be x to the fourth. So this is just an example of an exponential relationship where you multiply by the same number over and over again. Okay? Alright, so let's take a look at these tables right here. We're going to use actual numbers now. This is just a general case. So for the first one, you go 6 to 9. Alright, so if you want to go from 6 to 9, so if you multiply by, let's say you multiply by 3 over 2 to go from 6 to 9, and multiply 9 by the same number, 3 over 2, you're not going to get 12. All right, so this doesn't look like an exponential relationship. So let's try addition to see. So from 6 to 9, what if we add 3? Does the same common difference hold for other output terms? Well, let's see. What is 9 plus 3? It's 12. Oh, looking good. 12 plus 3, 15. Perfect. 15 plus 3 is 18. So you see that we're adding, we have a repeated addition situation here, right? The common factor is 3 because that's a number you keep adding over and over again. Number 1 is a linear relationship. All right, that's not what we're looking for. We're looking for an exponential relationship identified by repeated multiplication. That's the key. Okay, let's move on to option 2 and see what's going on there. So from 2 to 7, 7 to 12, 12. What do you think is going on here? it's easy to see that it's an additive relationship. From 2 to 7, you add in 5, okay? Or you multiply by 7 over 2. If you multiply 7 by 7 over 2, you get 49 over 2, which is 24.5. That's not 12, right? So it's clear that we're adding here. So if you add 5 to 2, you get 7. If you add 5 to 7, you get 12. Nice. If you add 5 to 12, you get 17. And if you add 5 to 17, you get 22. Ladies and gentlemen, you can clearly see that this is a linear relationship because you're adding the same common difference of 5 over and over again. Alright, so this is a linear relationship, so it cannot be number 2. We're looking for the exponential relationship here. Okay, so let's say we could look at number 3. So number 3, let's say from 4 to 12 you add 12. I'm sorry, from 4 to 16 you add 12. If you add 12 to 16, you get 28, but that's not what's here. So clearly this is not linear. This might be what we're looking for. Let's try multiplication, okay? What if we go 4 times what gives you 16? 4 times 4, okay? 16 times 4, 40 plus 24, 64. Oh, looking good. 64 times 4 is going to be 240 plus 16, 256. Excellent. So what's going on here is repeated multiplication. 250 times 4, I'm sorry, 256 times 4 is the same thing as 250 plus 6 times 4, which is 1000 plus 24, which is 1024. Bam. Ladies and gentlemen, we have repeated multiplication by a constant factor. What kind of relationship is that? Exponential. So ladies and gentlemen, this is the solution to the problem. Okay? Answer to this one is option number 3. So let's just do 4 just to make sure that we're doing it correctly. Alright? So for number 4, we have negative numbers here. Well, the signs are the same, so we know that we're subtracting. I'm sorry, the signs are the same, and the number is increasing in magnitude, which indicates repeated subtraction or multiplication. We don't know yet. Let's try repeated subtraction to see if that's the case. Okay, so to go from 9.5 from negative 9.5 to negative 12. You're going to advance 0.5 to 10 and then 2 more to 12. So that's equivalent to subtracting 2.5. Bam. Now from negative 12 to negative 14.5. If you subtract negative 2.5 from 12, it's the same thing as adding 2.5 to 12 and then keeping the sign, right? That's going to give you 14.5. What happens when you add 2.5 to 14.5? 14.5 plus 2.5 is positive 17. Keep the sign is negative 17. So it's negative 2.5. And then the last one, we can easily see the same pattern, negative 2.5 also. So this, ladies and gentlemen, is a linear relationship. Why is that? Because you're subtracting the same number over and over again, or you can think of it as you adding a negative number repeatedly, which makes it linear. All right, answer to question to this problem is option number 3, the exponential relationship. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel. Tons of support resources can be found on Mathgotserved.com. If you have any questions, specify it in the comment section below. Thanks again for watching, and we'll see you in the next video. Goodbye.